Okay, in this video we're going to actually go through and solve some projectile motion problems, and I think I've got about 5 practice problems to put into this video. So before we start, I wanted to make sure that you have your guided notes out. We're in Chapter 5 guided notes, and there's where you're going to find those practice problems. And I hope that you write down everything that I write down as we go through these problems and follow the same kind of steps that I follow. Before we start, though, I wanted to go back to the equations, and I want you to have that this list of equations out. As we talk about these problems, we're going to use these 5 equations. So please have that paper out, a calculator, and some space to work. All right, let's get started. I've come up with some steps to solving projectile motion problems, and I think if you will follow these steps, it makes these problems about as easy as I can make them. So number 1, we're going to draw a picture of the situation. Now, I'm not a very good artist either. I just draw stick figures, but I think if you draw a picture, it really helps you to visualize what the problem is really asking you about. So draw a picture. Number 2, we're going to separate the vertical and the horizontal components. Remember, components means parts of the projectile's motion. So we can separate the vertical and the horizontal components of motion, and I'll show you how we do that in these problems. Step 3, we're going to write down all the known variables. Remember from the previous video, there's 7 total variables. Step 3 is to write down all the ones that are known, which are given in the problem. Step 4, we're going to write down all the unknown variables. So out of those 7, the unknown ones are the ones that are not given in the problem. These are the ones we're just going to put a question mark by because we don't know what they are. Step 5 is to remember time is the same for both the vertical and the horizontal components. The time that a projectile spends in the air is the same vertically as it is horizontally. And so we're going to solve for time first. Okay, going back to these steps, I really think if you will follow these steps, and I'm going to go through and re-emphasize them every practice problem that we go through. So draw a picture, separate the vertical and horizontal components of its motion, write down all the known variables, write down all the unknown variables, and then solve for time. And I think if we do those 5 steps, these problems will be pretty easy. Okay, practice problem number 1. So let's read it and then we're going to go through those steps. So it says a rock is dropped off a cliff. How fast is it moving after 2.5 seconds? Okay, step 1, let's draw a picture. Like I said, I'm not a very good artist. I'm just using stick figures, but I'm just trying to help me visualize what's happening in this problem. So you're on a cliff and you drop this rock. And we want to know how fast it's moving after 2.5 seconds. Okay, so that's step number 1. We drew our picture, and there it is. Step 2 says to separate its components of motion, so vertical. So I want you to write vertical and then horizontal. Okay, but in this problem, we don't have horizontal motion. It's all vertical. And so we're not going to use this part right now. We'll get to that later. But everything in this problem is going to be vertical, so let's list it under the vertical component. Okay, we're going to list all the variables that we know. I like to put the variables right on the picture itself. So there's 7 variables, remember. And we're going to go through them and list all of them right now. This point at which you release it, we're going to say that's displacement initial. That point at which you release it, we're going to call 0, because there is no displacement. It hasn't traveled any distance yet. Okay, there's one variable. Let's go to another one. Time initial. Time initial is 0, and it will usually be 0 unless the problem tells you to start at a different time point. But we're going to start with time is equal to 0 right here. Right as you release it, time is 0. Okay, let's go to velocity initial. Now imagine if you're just releasing it, its velocity has got to start from 0. So there's 3 variables that we know. Let's list another one that we know. Acceleration of this rock after he drops it is going to be a negative 9.8 meters per second squared. Again, why is it negative? And the answer to that question is it's going down. And down in physics, we put a negative sign. So that negative sign is going to be important to us. Okay, now let's list some of the variables that we, well, there's one more variable that we know. It says after 2.5 seconds. So it's going to come down, and after 2.5 seconds, that's what we're going to call time final. So time final is 2.5 seconds. Now let's list the variables that we don't know. Velocity final. We don't know how fast it's going to be going at that point. And we don't know displacement final. So I'm just drawing question marks by those. And again, all of this would be vertical component of motion. So now what I like to do is circle what it's asking us to find. It says how fast. So if you're going to pick a variable to solve for, we want to know how fast it's going after 2.5 seconds. So that's its velocity final. Okay, now we've got to pick an equation. So hopefully you have that equation sheet that I passed out in class. But there's also the equations in your guided notes. What I'm going to do right now is just go through those 5 equations. And ask yourself, can you use this equation? Number 1, can you use equation number 1? And the answer is no, because equation number 1 is only for horizontal motion. So we're going to skip equation number 1 and go down to equation number 2. Let's see if we could use equation number 2. Equation number 2 starts with velocity final, so that's what we don't have. So okay, that's good that it's included in that equation, but we've got to have all the other variables. Do we have velocity initial? The answer is yes, it's 0. Do we have acceleration? And the answer is yes, it's negative 9.8. And do we have time? And time final was 2.5, so we can use that equation. So let's write that down. Velocity final is equal to velocity initial plus AT. Now I'm just going to plug in our magnitudes for these variables. Velocity final, we don't know, so I'm just going to keep calling it V sub f. Velocity initial, if we just drop it, it's got to start at 0, so that's going to be 0, plus the acceleration, and we really should put g here for the acceleration due to gravity, is a negative 9.8, and time stands for time final, which is 2.5 seconds. Okay? And so if we simplify this equation, velocity final is going to be equal to a negative 9.8, let me put that in my calculator, times 2.5. And you're hopefully getting this answer. It's a negative 24.5, and the units for velocity are meters per second. Okay. So let me ask you, why is it negative? Why does it have a negative final velocity? And the answer to that is that the rock was dropped, so it's traveling down, and down in physics is negative. So that's just kind of one example of using all those steps in solving a typical projectile motion problem. All right, let's move to the next one, practice problem, and it looks like we did get that one right. It should be negative because it's going down. So let's go to practice problem number 2. And go through the same steps that we just went through. It says a ball is dropped off a cliff. How much time does it take to reach a velocity of 32.5 meters per second? Now step number 1, we're going to draw a picture. So again, we have a cliff. Okay, and here we are. You're going to drop this, the ball off that cliff. And it tells us that the velocity is 32.5, but we're really looking for how much time that takes to get to that speed. So step number 2, we're going to separate the vertical. So I'd like you to write vertical and then horizontal in your notes. Now again, if we're dropping it, is there going to be any horizontal motion? And the answer is no. So we're going to put a big X on that one. We'll use that eventually, but not in this problem. Okay, so let's go through. Step 3 was to list all the known variables. I like to start at the point at which you release it. Displacement initially is going to be 0. Remember, we have 7 variables we need to list. Time initial is going to start at 0. And velocity initial, again, if you're dropping it, it's got to start at 0 meters per second. So that's the point at which we release it. We also know its acceleration is going to be a negative 9.8 meters per second squared. I should probably call it g because it's the acceleration due to gravity. Now let's list one more that we know. It said when it reaches a velocity of 32.5. That's going to be down here somewhere. So we're going to call that velocity final. And that's going to be 32.5. But again, this ball is traveling down, so it's going to have a velocity of a negative 32.5. Remember, the sign notation is very important when you solve these problems. If it's going down, it's got to be negative. Okay, a couple of variables that we don't know is time final. So I'm going to put a question mark by that one. And displacement final. Okay. So now I've got all 7 of those variables. There's 3 here, 4, 5, 6, 7. And so I've accounted for all 7 variables. Once you get them all labeled like that, and you've got the magnitudes for them, now you just got to figure out what the problem is asking for. It's saying how much time does this take? So which variable are we going to be solving for? And I like to box it or put a circle or a star by it so that we know that's the one we're going to be solving for. So our equation that we pick better have time final in it. So now let's get our equation sheet and look through those 5 equations. Number 1 again is a horizontal equation, so we're not going to use equation number 1. Number 2, now if you look at number 2, let's see if we can use it. It starts with velocity final, which we have, equals velocity initial, which we have, plus acceleration, and we have acceleration. And so the only variable that we don't have is time. So I'm going to pick equation number 2 to solve for time. Let's write the equation down. So velocity final is equal to velocity initial plus AT. Now that we have the equation written down, let's plug in our variables. Final velocity goes here, and that was a negative 32.5 meters per second, is equal to the initial velocity was 0 plus acceleration is a negative 9.8, and time final we don't have, so I'm just going to keep calling it T sub f. Okay. And so now let's simplify this equation as much as we can. So we have a minus 32.5 is equal to, I'm going to leave off the 0, and because this is negative, I'm going to put a negative 9.8 times t. Okay, now we want time final to be by itself, so how do we get rid of this negative 9.8? And the answer is you've got to divide this equation by a negative 9.8 on both sides. Over here, you'll notice that it's dividing by itself, so it's going to cancel out. So time final is equal to a negative 32.5 divided by a negative 9.8. So if we do that, negative 32.5 divided by a negative 9.8 in your calculator, and so time final, if you solve for it, should equal 3.32, and the units for time are seconds. And so hopefully that makes sense. Again, it's a negative divided by a negative, so time is going to be positive in this case. And time should always be positive. You can't have a negative time value. So if you get a negative time value, you got to look at your sign notation over here and make sure you've got all your signs in the right spot. So. Okay, there's another example. Hopefully practice problem number 2 made sense. Let's go to practice problem number 3 and try again. It says you drop a rock off a bridge that is 40 meters high. How long will it take the rock to hit the water below? Also, how fast is it moving right before it hits the water? Okay, so there's a little bit more going on in this problem, but again, we're going to use the same steps. Step number 1 is to draw a picture. So let's draw a picture of this scenario. This time we're dropping it off a bridge. So let me see if I can draw a bridge. Okay. And it says it's hitting the water below, so this bridge has got some water down here. Okay, here you are on the bridge, and you're dropping this, it's a rock. So you're just dropping it, so I like to draw the path of the projectile. It's going to go straight down. Okay, step 2 is to list the vertical, or break up the motion, so into vertical component and horizontal component. So vertical, and then I would like you to write horizontal off to the side. Okay, but again, if the rock is being dropped, it's just going to have vertical motion. It's not going to have horizontal motion. So there will be nothing under the horizontal component for this problem. Step number 3 is to list all of our known variables. I like to start at the point at which he releases it. Displacement initial is 0. It hasn't traveled any distance yet. Time initial is going to start at 0 as well, 0 seconds. Let's see what else. Oh, velocity initial. What is the velocity initial? If you're dropping it, it's got to start from 0. Okay, another variable that we know is acceleration is going to be equal to a negative 9.8 because it's accelerating down. Gravity is pulling it down toward the center of the Earth. And let's see, there's one more variable that we know. It said that the bridge was 40 meters high. And so we know displacement final down here is going to be, so if the bridge is 40 meters high from where you release the rock, isn't the rock going to end up below where you released it? So I'm going to say that displacement final is a negative 40 meters. Again, negative because the rock is going to end up below, so its displacement has actually gone down, so it's a negative 40 meters. That's going to be important. The sign notation is very important here. Okay, now there's 2 variables that we don't know, which was time final, so I'm going to put a question mark, and we also don't know velocity final. Okay. So now let's go back up and figure out what this problem was asking us. It says, how long will it take? So how long? That means we're going to be solving for time final. But then it also says, how fast is it going to be going right before it hits the water? So we're also going to be solving for velocity final. Okay, I've got all 7 variables listed, the known and the unknown. We've figured out what it's asking us for. Let's go to our equation sheet, those 5 equations, and just go down the list until we find an equation that we can use to either solve for time or velocity final. So equation number 1 is out because that's only a horizontal equation. So let's go to equation number 2. Equation number 2, let's look at it. Do we have velocity final? And we don't. So it's equal to velocity initial, which we have, plus a, which we have, plus t. Now, if you look at equation number 2, it has 2 unknown variables in it. There's no way we can solve equation number 2 because we don't have 2 of the variables. So we can move on from equation number 2 or cross that one out for this problem. Let's go to equation number 3. Displacement, which we have, it's a minus 40, is equal to 1/2 the velocity final, which we don't have, plus velocity initial, which we do have, times t. And again, we have 2 equations or two variables in that equation that we don't have. So we can't use equation number 3 either. Let's go to equation number 4. Displacement is equal to, and we have displacement, velocity initial, which we have, time we don't have, plus 1/2 a, which we have, times t squared. Okay, so there's an equation that we can use, because in equation number 4, we only have one variable that we don't know, and that's time. So let's use equation number 4 to solve for time. Let me write that equation down here. So displacement is equal to velocity initial times time plus 1/2 at squared. All right, now I'm going to go and plug in the magnitudes of these variables. So displacement here is for displacement final, which is a minus 40, is equal to velocity initial was 0 times t plus 1/2. A is a negative 9.8, and t we don't have, so I'm going to call it t, but it's squared. Okay. Now let's simplify this equation as much as we can. So we got a minus 40 is equal to 0 times t. Anything times 0 is 0. So I'm going to leave that off. So I'm going to simplify this. Let's take 1/2 times negative 9.8. So 0.5 times negative 9.8. On my calculator, it says it's a negative 4.9. So a negative 4.9 t squared. Okay, so now we've got the equation simplified as much as we can to this point. I want t by itself. So how do I get rid of this minus 4.9? And the answer is we have to divide this equation by a negative 4.9 on both sides. Okay. Over here we're dividing it by itself, so it cancels out. So now we have to figure out what a minus 40 divided by a minus 4.9. So now I'm getting that t squared is equal to 8.16 seconds. Okay, but I really am trying to solve for just time, not time squared. How do I get rid of the time squared? And the answer, to get rid of a square, you've got to take the square root. But again, this is an equation. Whatever you do to one side, you've got to do to the other side. And so when you take the square root of t squared, you get t is equal to the square root of 8.16. And if you do that, time is going to be equal to 2.86. And again, the units for time are seconds. So, okay, we used equation number 4 there to solve for time. So the amount of time that rock will be in the air before it hits the water is 2.86 seconds. Now, that's pretty cool. If we know how high the bridge is, we can figure out from these equations how long it's going to be in the air, which is, I think, pretty cool. But that's not all this problem wanted us to solve for. It also wanted us to know, to figure out how fast it's going to be going right before it hits, which is velocity final. Okay, so let's pick an equation with velocity final in it that we could use. Again, number 1 is out, because that's a horizontal equation. Let's go to equation number 2. Velocity final, we don't have, is equal to velocity initial, which we do have, plus a, which we do have, times t. Now we do have t. Let's use equation number 2 to solve for final velocity. See, I'm kind of running out of space. I'm going to solve for it up here. So let me write down equation number 2. Velocity final is equal to velocity initial plus at. So now let's plug in our variables. We don't know what velocity final is. We know that velocity initial was 0, plus a is a negative 9.8, and t we just solved for was 2.86. Okay. And so velocity final is going to be equal to a negative 9.8 times 2.86. So let me put that in the calculator. So negative 9.8 times 2.86. And I'm getting that velocity final is equal to a negative 28.0. And the units for velocity are meters per second. So why is it negative? Well, the answer to that question is that it's going down. It has a negative velocity because the rock is traveling down. So kind of a cool problem. Hopefully you think that it's pretty cool. We can know we just calculated how much time it's going to be in the air before it hits the water below. And we can calculate how fast it's going to be going when it hits the water, which is pretty cool with these equations. All right, I've got a couple more problems here. So practice problem 4 and 5 left. So let's go to 4. Oh, first of all, we did get the answer correct. So 2.86 seconds and 28 meters per second. Good. Practice problem number 4. It says you throw a ball straight up with an initial velocity of 15.5 meters per second. How high will it go? Okay, so this one's a little bit different. Let's draw the picture. Step number 1, draw a picture. Okay, we're standing on the ground. We're going to throw this ball straight up. Okay, it's going to go up at some height, and then it's going to come back down. Okay, and so there's our picture. Now, step 2, let's separate the vertical and the horizontal components of its motion. And step 3 says to list all of the known variables. I always like to start with the very beginning of this problem, right where he releases this ball. So displacement initial is equal to 0. It hasn't left your hand right at that moment. It hasn't traveled any distance, so it's 0. Time initial is also equal to 0. Velocity initial, now this one, it says it had an initial velocity of 15.5 meters per second. So we're not just dropping this one, we're throwing it. So it does have an initial velocity. Okay, we know that as it's flying through the air, the acceleration is going to be a negative 9.8 meters per second squared. And let's see if there's something else we know. We know there's got to be 7 variables that we need to account for. So it says, how high will it go? So we're looking at this point up here at the very apex of its flight. And so we're going to call that displacement final. And we don't know that one. But time final is another one that we don't know. But there's one more variable that we do know. I want you to think about this one. What is the velocity final at this point, at its highest point? How fast is it going to be going vertically? And the answer to that, if you imagine the ball is going to come up at its highest point, it reaches a velocity of, hopefully you're saying 0. Because when you throw a ball up, it's going to reach its highest point. There's going to be a moment in time where its velocity is 0, and then it's going to start to come back down. And so whenever you're solving these problems and it wants to know how high it's going to go, just realize at its highest point, its vertical velocity here at its highest point has got to be 0. And so that's kind of the key to this problem. So I've got all 7 variables listed. Now let's figure out what it wants us to solve for. It says, how high will it go? So we're really solving for displacement final. So please, I always like to put a circle around that one. So we need an equation that has displacement final in it. Let's go to our equation sheet and pick one. Equation number 1 is out because we don't have horizontal motion, and that equation is only used for horizontal motion. Equation number 2 we can eliminate pretty quickly. How come? We're solving for displacement final. If you look at equation number 2, it doesn't have displacement in it. So cross that one off our list for this problem. We're not going to use it. Let's go to equation number 3. It does have displacement, so that's good. But let's see if we have all the other variables. Do we have final velocity? And we do. Do we have initial velocity? And we do. But do we have time? Time final, that it's in the air? And the answer to that is no. So we can't use equation number 3 because we don't have time final. Let's go to equation number 4. It's got displacement, which we want to find, but we don't have it. So we've got to have all the other variables. Do we have an initial velocity? And we do. Do we have time? That would be time final. And we don't. Okay, so we can't use equation number 4 because we don't have time either. Let's go to equation number 5. Hopefully we can use equation number 5 here. So equation number 5 is velocity final squared, which we do have, it's 0, is equal to velocity initial squared, and we have that one, plus 2 times a, which we do have, and d. So equation number 5 we can use because we are looking for d, and that's the only one that we don't have. So velocity final squared is equal to velocity initial squared plus 2AD. Now let's go through and plug in these variables. Velocity final was 0, so 0 squared is equal to, velocity initial was 15.5. And notice how it's positive this time because we're throwing it up, so the velocity is going to be positive. But remember, we've got to square it. Plus 2 times a. A was a negative 9.8. Times d for displacement. And remember, that's the one that we're solving for, displacement. Okay, let's go through and simplify this equation as much as we can. 0 times 0, or 0 squared is 0. Is equal to 15.5 squared is equal to 240.25 plus 2 times a negative 9.8 is a negative 19.6 times d. So if I simplify this a little bit more, I've got 0 is equal to 240.25. Now, plus a minus, I'm just going to say that's a minus 19.6 d. Okay? Now we've got an equation, we have an unknown in it. I would like to get this term to be positive. So what I'm going to do to get this term positive, because it's got our displacement in it, is to add 19.6 d to both sides. Okay? And when we do that, it cancels out on the right side. And so 19.6 d is equal to 240.25. And now I've got to get rid of this 19.6. So what I would do to get it away from the d is to divide it by itself, 19.6. But we've got to do that to both sides. So 19.6 divided by itself cancels out. And so our displacement is equal to 240.25 divided by 19.6. And so my displacement is 12.3. Let's see. 12.3, and our units for displacement is going to be meters. All right, so that's kind of a cool problem. If you know how fast you can throw in meters per second, you can figure out how high you can throw it by using equation number 5. And I think that's pretty cool. So it would go 12.3 meters high. And everything turned out okay in this problem because our displacement was positive. Why is it positive? Because the ball at its highest point is above where you released it. And so it's going to be positive. So anyway, hopefully that helps with that type of a question. I've got one more practice problem in this video, and it's a complicated one. Practice problem number 5, and we did get that one right. Practice problem number 5. So please pay attention to this problem. This one's going to be a little more complicated. So it says you throw a ball straight up in the air at 15.5 meters per second. Your release point is 1.7 meters above the ground. How long will it take for the ball to hit the ground? Okay, so there's a lot going on here. I think if you follow step number 1, which is to draw a picture, let's do that. Okay, so here you are. You're on the ground. Okay, you're going to throw this ball up into the air. But it says your release point is 1.7 meters above the ground. That's going to be where this problem gets a little complicated. So let's draw the path of the ball. Okay, it's going to go up, and then it's going to come straight back down, but it's going to end up 1.7 meters below where you released it. So we're going to get to that. That's where we're going to have to define a few variables there in just a second. Step number 2, though, let's go to step number 2. It says to separate your vertical and your horizontal components of motion. But again, in this problem, we're not going to have any horizontal motion, so we're not going to fill out this column here. Let's go to the vertical column. Let's list all the variables that we know. We know there's got to be 7 variables total, so let's start with what we know. At this point, where you release it, the displacement, I'm going to say initial, is 0. And that's because it hasn't traveled any distance from our hand yet. Time initial is also 0. And velocity initial, it did tell us in the problem that it had an initial velocity of 15.5 meters per second. So that's going to be, again, 15.5 meters per second. Now, when we do our, well, I guess we know one more. The acceleration of this ball is going to be a negative 9.8 meters per second squared. And now let's go to where it's going to end up. It says that the release point is 1.7 meters above the ground. So the distance from here to the ground is 1.7 meters. We're going to account for that in this variable, displacement final. So think about this for a second. What would you put for displacement final? Again, from here to the ground is 1.7 meters. But if we're calling this point displacement initial is 0, the ball is going to end up below that point. So I'm going to say that it's a negative 1.7 meters. Again, negative because it's ending up below where we started. Okay, and let's see, there's 2 more variables that we need to list, and that will be velocity final, which we don't know right before it hits the ground, and we also don't know time final. I'm going to put that over here somewhere. Time final, we don't know. Now let's go back up to the problem and figure out what it really is asking us to find. It says, how long will it take for it to hit the ground? So we're going to throw it up, and we want to know how long it takes to hit the ground. So really, we're going to try and solve for time final. So that's what we will solve for. Okay, so again, we're solving for time. So now let's go and we got to pick an equation that will help us solve for time. So hopefully we find one with time final in it. Equation number 1, it's out because we don't have any horizontal motion. Equation number 2, let's see if we can use it. Velocity final, we don't have. And we also don't have time, which is on the end of that one. So we have 2 variables in equation number 2 that we don't have. We can't use it. So scratch out equation number 2 for this problem. We can't use it. Number 3, let's see if we can use it. There's time that we don't have, but there's also velocity final that we don't have. So again, on equation number 3, there's 2 variables we don't know. We can't solve it, so scratch that one out. Equation number 4, let's check it. Displacement final we have, velocity initial we have, time we don't have. Well, time's the only one that we don't have, so we could use equation number 4. In fact, that's the one that we have to use because equation number 5 doesn't have time in it at all. So I'm going to write down equation number 4, which says displacement is equal to velocity initial times time plus 1/2 at squared. Okay. Now let's plug in the variables. For displacement, I've got a negative 1.7 is equal to, velocity initial was 15.5 times time. Time we don't have, so I'm just going to keep it as t, plus 1/2. The acceleration is a negative 9.8 meters per second squared. And time we don't have, but you got to square it. Okay? So let's simplify this equation as much as we can. Let's simplify this equation as much as we can here. So I've got a minus 1.7 is equal to 15.5t. And I've got a plus and then I've got a negative here. So I'm just going to say it's a negative. And so we've got to take half of 9.8. So it's a negative 4.9, but I've already put my negative sign in, so I'm just going to say minus 4.9. And t squared is t squared. Okay, this is what makes this problem a little complicated. You might be noticing at this point that this equation looks like a quadratic equation. And when we have a quadratic equation, I think it's best to make this t squared term positive. So I'm going to move it over to the other side of the equation. How do you do that? Well, you add 4.9 t squared to both sides. So we're going to have 4.9 t squared minus 1.7 is going to be equal to 15.5 t. And with the quadratic equation, I'd like to get all of these terms on one side and set it equal to 0. So how do we get this other term, this 15.5t, onto the other side? And the answer to that is subtract 15.5t on both sides. So minus a 15.5t. Okay. And I always like to put, and then that will equal 0 on this side because that cancels out. I always like to put my t squared term on the far left, so it's going to be 4.9 t squared minus the 15.5t minus the 1.7, and that's going to be equal to 0. And so this is a quadratic equation. There's a few ways you can solve a quadratic equation. We're trying to solve for t here. There's a few ways we could do it. One way is to factor a t out, but with these numbers that we have, it's going to be very difficult to do. You can complete the square, and that again is going to be almost impossible to do. Or you could graph it if you have a graphing calculator. You could graph it and see where it crosses the x-axis. But we don't have graphing calculators, so there's one more way we can do to solve a quadratic equation, and that's to use the quadratic formula. And hopefully you remember how to use the quadratic formula. I'm going to write the quadratic formula on the board, and if I were you, I would jot this down on your notes somewhere. Maybe even on your equation sheet that I gave you. So the quadratic formula, you've probably learned it as x is equal to, but we're solving for t, so I'm going to put t is equal to a minus b plus or minus the square root of b squared minus 4ac all over 2a. And so just as a little review, if you haven't had your math class about the quadratic formula for a while, let's review. There's a whole bunch of letters here. So we got B, A, and C, and another A. So where do we get these? What do they mean, these letters? And here's the answer to that. This coefficient here, this first one on the squared term, is your A value. The minus 15.5, the coefficient for this t term is your b, and again that includes the minus sign here. And this minus 1.7 is your c value. So when we're plugging in our variables into the quadratic formula, that's where we get the a, the b, and the c from. Okay, so let's go through and solve it using the quadratic formula. Again, here it is. I'm going to probably work the rest of the problem down here. So t is equal to, now a minus b, but our b is already a minus 15.5, so a minus and a minus is just positive, so I'm just going to call it 15.5 plus or minus, and I'm going to put in these terms here. We've got b squared, so a minus 15.5, well, the square root of b squared is a minus 15.5 squared minus 4 times a, 4, and our a term was 4.9, times the c value, which was a minus 1.7. Okay? All over 2 times a. So 2 times our a value was 4.9. All right, and so now we have all of our variables plugged into our quadratic formula. Now what I would like to do is simplify it as much as we can. And what I like to do is simplify what's underneath this square root sign. I like to simplify what's under that first. So let's do a negative 15.5 squared. And when you times negative by a negative, you get a positive. And so let's just rewrite this whole thing. T is equal to 15.5 plus or minus. And 15.5 squared is 240.25. Minus, there's a minus sign here. Now let's take 4 times 4.9 times negative 1.7. And I'm getting a negative 33.32. Okay. All over, now let's do 2 times 4.9. And that's 9.8. All right. And there's a parentheses right there. Now let's look at it. Let's again simplify what's underneath the square root sign. So I'm going to do t is equal to 15.5 plus or minus the square root. Let's do 240.25. Now what's a minus minus a minus? Well, that's going to be plus. And so 240.25 plus 33.32. And I'm getting 273.57. All over 9.8. Okay. Now what I'm going to do is take the square root of this number. So t is equal to 15.5 plus or minus. So the square root of 273.57 is equal to 16.54. All over 9.8. Okay, so we've got it simplified almost as much as we can. What we see here that's a little bit different with the quadratic formula is this plus or minus. And the reason for that is we're going to have two answers for t. This is a quadratic function. So to get one answer for your t value, or time value, we're going to take 15.5 plus this number, then divide it by 9.8. And for your other value, we're going to take 15.5, subtract 16.54, divided by 9.8. So let's do this one first. So 15.5 plus 16.54, and then divide that by 9.8. And so one of my t values is going to be equal to 3.27, and time is, the units is seconds. But we've got to do this, really, we should do it twice. and go 15.5 minus 16.54 divided by 9.8. So let's do that now. 15.5 minus 16.54 divided by 9.8. And so I'm getting that time when we do that one is negative 0.1 seconds. Okay, so we get two time values. But if you look at them, can we ever have a time value that's negative? And the answer to that is no. Okay, we're not going to report that one as our answer. Our answer is going to be this positive value because time will always be positive. So the amount of time that that ball is in the air, if you throw it up and it ends up 1.7 meters below on the ground, the amount of time for it to do that will be 3.27 seconds. And I think that's really cool how we can use equations to solve these projectile motion problems. And hopefully that helps give you a good introduction on how to solve them and all the different formulas that you can use and different math techniques that we use to solve for those variables. But before we end the video, I wanted to give you some more practice with this. So in your student workbook, there's a worksheet called Free Fall Review Worksheet. Please go there now and complete that worksheet. You should know how to do all of those problems. Again, it's called Free Fall Review Worksheet. And if you use these same steps, I promise, it makes these problems pretty easy. And hopefully that helps.